Hi there, and welcome to Context Free, where we talk about programming languages. Today, I'm excited to welcome guest gingerBill, the creator of the Odin programming language. Odin is a C alternative designed for enjoyable, high-performance modern systems programming. And as usual, before we go into the interview, let's take a look at a demo. This demo code came from gingerBill himself after he talked through what might make a good example, and I've modified it only slightly. Let's take a look at it. And note that this demo includes the use of the official bindings for SDL and OpenGL, which ship along with Odin itself. And before we look at the code, let's actually run the demo, because visual demos are fun. So you see that Odin uses colons to assign constants and equal signs to assign variable values. The first colon in each of these cases has an inferred type behind it and is used for initial declarations. We see that Odin uses the word proc for procedure, and we have defer functionality for cleaning up our resources. Some of the syntax might remind us of Go, but other things are very different. For example, Odin has no garbage collection. If we skim through the code here, we'll find other interesting things, such as this struct definition, of which we can then make arrays, and initializer structs either with named fields or positionally. We have a label for our loop, explicitly partial switches, inferred namespaces in this context for our enum values, and noting here the use of our label for the break. Odin also has vector and matrix notions built in for bulk operation on them, and swizzling like you might see in shader languages. Down at the bottom, we also see an example of multi-line strings. And of course, like all short demos, this is only a sampling of language features, but it helps us get a little bit of a feel of the language. And for the interview itself, like usual for me, I've chosen some visuals after we had the conversation. Let's get started. So could you please introduce yourself?
Hi, I'm gingerBill. I'm the creator of the Odin programming language.
Awesome. And how did Odin get started?
Odin got started in late July of 2016 when I was kind of getting annoyed with C++. But the reason as to why I started back in the beginning of 2016, where I had New Year's resolution where to start every single project in C, new projects in C, because I wanted to find out what I wanted from a language. And every project I started kept it. And eventually I started making tools to improve my things, augment C. I effectively made a C front end, adding new features, because even C++ didn't have the features that I wanted to improve it. By July time, I was getting, C's a dead end, C's fundamentally broken, I'm going to have to make my own language.
Okay. And so you mentioned starting Odin with begin and end syntax. And you mentioned separately also that Pascal has been one of the inspirations for the language.
Yes.
So what was interesting about Pascal, and also just on the syntax level, which is still, I find interesting, why did you switch to curly braces?
So again, I started as a Pascal clone because I knew there was a lot of kind of hidden nuggets inside Pascal, which were kind of forgotten. And I wanted to see where would that lead. And I'm a big Niklaus Viet fan in general, so I wanted to see what he was doing and just go along with that. I kept getting annoying typing begin and end, mainly because it's easy just to write curly braces. I literally have to do one key, and then most text editors will just close them. Begin and end, you have to type a lot. It was just literally laziness. It was nothing to do with aesthetic reasons or anything of that case in there.
Okay. So you also mentioned joy of programming as one of your motivations in Odin. Ruby also claims to be designed to improve programmer happiness. What does this mean to you?
For me, we've all got into programming because we love to solve problems. Why shouldn't our tools bring us joy while doing it? And we don't have to dredge, and it doesn't have to feel like we're filling in a tax form when we're programming. We want to actually enjoy doing it and let it do the thing it wants. And usually many languages will get in a way because they'll tell you how to program. You should program like this. And it's like, no, I know what I'm doing. I want to do this particular way. Just get out of my way. At certain times, of course, you have restrictions, but a lot of the time, like Ruby has a different philosophy of me, clearly, and how many things. But in general, many languages have kind of been trying to put a cost on the programmer and saying, hey, we want to make our programs correct, rather than saying, trusting the program, saying, actually, you know what you're doing, here's the tools.
And in terms of the C replacement space, which Odin is in, how does Odin's philosophy differ from other languages in this space?
So Odin is trying to be a C alternative in certain domains. No one's ever going to replace C, in my personal opinion, because C is actually not even one language. It's different on virtually every single platform you'll go on. Especially in embedded systems, you'll see like they're not even real true C compilers. They do not give a damn about the spec. They'll just do whatever. But for me, I've been trying to design Odin for high-performance modern systems and doing that type of niche. So I'm trying to exploit low-level control over memory layout, memory management, custom allocators, and so much more. and design it from the bottom up for modern computers. Modern computers now have SIMD in them, have SOA data types built into Odin. You have array program built in. It's trying to take what the actual computer can do nowadays and try and, okay, how do you put that into a modern language and design a modern language around that?
Awesome. So in terms of Odin features and how it presents itself, Odin uses the keyword proc for procedure rather than the term function. Do you have any intention to support special handling of pure functions in the future?
So short answer is that no, but there's actually a really good reason for this. So the reason why I used procedure is that depending on which dictionary people use in conventions, procedure is a more generalized term. So a function is usually meant to mean in the pure sense. So the same inputs will give you the same outputs. You can then have the word subroutine, which means it has no return. It just does some logic. You pass data into it and does logic. And then you have procedure, which is the category over them, which includes both subroutines and procedures and mutability and immutability of such, like pure, non-pure. So it's just a general term I used. I did consider at one point thinking, okay, should I have this idea of a pure function? And it turned out to be a very bad idea, actually, in Odin, because it was very not useful. Odin is fundamentally an imperative procedural language, and it excels in that domain. If you try and put more functional things in, it's completely like jerry-rigging it. It doesn't work very well. And it's more like, okay, you can add this feature, which is very rarely going to be used anyway, and it doesn't really have any benefits because you can easily just get around it unless you do some very strict things. It's losing that joy of programming is one thing to doing, but it also has very little utility once it's been implemented. As I'm not against functional programming, I should be very clear here. It's just I don't think you should try and make a language something it is not.
And in terms of other things about Odin, why use manual error handling?
So for me, firstly, I try to find this concept of error. So it's a very interesting topic. I've tried to research into it a lot as well. But for me, error values, I don't think there's anything special. So Odin has no built-in concept of an error value or an error type. Many new languages do, and many languages in general do, like especially with exceptions. Odin was kind of say, look, error values are just error states. They're just failure states. They're just different pieces of logic in your code. So you should handle them as if they are. They're very rarely exceptional, it says, so you shouldn't be doing exceptional approaches to them. So just try and do that. Now, Odin does have some nice built-in features to aid with like common error value handling systems. So stuff built in, like for instance, we've got the or return operator, which is where you apply it to the end. And what it does is it fictly checks this, okay, because Odin has multiple return values, it goes, okay, this value here is the end value of this multiple return of this multiple value. It says, oh, is it nil or not, or is it false? If so, then return that's in the last value of your procedure. So it allows you to have some very nice shorthands, which are very common in many languages, like for instance, how multiple return like in Go, but it makes it much more shorter and much, much cleaner. But it doesn't still encode any concept of an error value into language. It just does it through different language constructs.
Okay, very nice. And one thing I spend a lot of time thinking about is integer sizes. It sounds weird. It sounds like a small thing, but it just ties me in knots. So I notice Odin's default int is pointer sized and Go does the same, but some languages instead target 32-bit integers by default, even on 64-bit systems, claiming either portability or performance reasons. How did you make your decision on the default integer size?
So the reason why is mainly for performance reasons. If your register-wise integer will usually be faster than a smaller one, of course. So 64-bit integer will be faster to do addition such than the 32-bit one for numerous reasons. But the other reason is that I want people to default to the register-sized one because that's usually what you want. The only reason people write type int a lot on like C is because that's what they're used to typing. Oh, it's an integer, I'll write that. But that's not necessarily the correct type. And again, the way that C originally wanted to do it was meant to be register type. But because of legacy reasons, especially like x64, they had to keep int the same because many people were relying on it being in 4 bytes. Now in Odin, I wanted people to use default to int rather than having some explicit, which I even use in my own C code. I use like isize and usize to say they are register-sized integers, unsigned and signed. And the thing was I wanted people more to default to the int, similar to how Go does this, of course, rather than having specific type sizes. Many of the time you do need specific sizes, but generally if you're just using a basic integer, using that as an index, or using it as just basic arithmetic, standard int is absolutely fine.
Okay. And I've noticed that you recently, well, somewhat recently, added SDL2 bindings to the Odin repo under a vendor directory as a sort of form of batteries included, I suppose. What do you think about package managers versus curated libraries?
So first off, I'm going to get clear. Package managers, in my opinion, are trivial things if and only if the concept of package is well defined within the language itself. So I've been trying to be very careful with the words I choose there. So for me, if the concept of a package is well defined in the language, then the actual package manager is about 4 or 5 tables in the database. It's not actually a complicated problem. It's very trivial to solve. The problem is when many of these package managers are trying to figure out how do you define a package. So that's where a lot of the complications come. The second issue with package managers is dependencies. You can download one package, and then you've now got hundreds of dependencies. You didn't even know what's going on, and they may be different versions, and you've got dependency hell. And if anyone's worked on a large project with loads of dependencies, you know that hell I am talking about. And so if you can try and minimize it, sometimes that means like package managers make it so easy to get in there because it's so easy to download. And like in Python, you got pip install and blah blah blah, whatever it is, and then it's so easy to download things, and that is great from a user perspective. That is dreadful from a project management perspective, and it's that balancing act of like, okay, how am I going to maintain this in the future when I've got thousands of dependencies of which I don't even know the code quality of them or and such. So that comes where Odin now has the vendor library collection, where these are heavily curated libraries which are third-party as well. They're third-party libraries such as SDL, OpenGL, GLFW, Vulkan, Raylib, Mini Audio, Port MIDI, and many other libraries to come as well, which are heavily crafted either ports, which a port would be micro UI, which are RxI's little lightness, little utility, or they are fundamentally just bindings, but designed specifically for the language and heavily crafted. Because that's one issue with package managers is very rarely you can get the quality as well, standard, because it can range from really high quality to absolute dreadful nonsense. So again, it's a very difficult thing. Like I don't really have much against package managers from a just prototyping standpoint, but when it comes to real projects, I try and stay away them as much as possible.
Back to Odin language features, why does it support runtime type information?
So there are many ways to do it. You could always do compile time type information or runtime type information. The main reason I originally added it is I wanted a runtime type safe printf. I wanted the ability to effectively serialize data and print it and format it correctly. But that's why I added it, and that's the main reason for it, and many things come from it. But as noticed to say in serialization, this allows me to write generic code, which is just singular and not polymorphic. So that means generics effectively, where then you just write it once and you can write serialization or deserialization code for that data types and you can just run it fine. You're already adding all those tables at the start beginning with. So even if you were doing it as compile time, instead of being tables, you've got code instead. But data code, it's kind of a trade-off which one you prefer. I prefer having smaller amount of code and just have a big, larger data section. Again, it's a bit of a trade-off. But again, I find runtime type information extremely powerful, especially when you're trying to make very generic code and reflection as such. Yes, there are dangers in it, of course, but there's dangers in any tool, especially when you've got raw memory. So can't really do much about that.
Okay, I didn't have it on my list, but Odin also supports generics to a certain extent also.
Yes.
So what do you make about choosing between the runtime versus the generics?
So most people shouldn't be touching the runtime type information reflection in general because most people don't require it. You'd be surprised. It's mainly for when you're needing those generic things, like you're making a generic serializer or a printf alternative and such. Beyond that, you'll very rarely need it, is one thing. Regarding generics or parametric polymorphism, if you want the technical term, I usually say parapoly for short because it's just easier to say. So parapoly in general is something I always tell many people rarely need it when you think. One thing when I was designing Odin was finding out what tools do actually people want and why do they use them? Why do people go to like templates in C++ a lot? And it's usually because they're missing like a language feature or they're missing a data structure built in. And it's usually just to create data structures. And that's mainly for it. I'm like, okay, that's the perfect case for parapoly generics. You make like, okay, red black tree, or you want a, I'm just trying to think of the data structures here, maybe just a hash map in general, whatever. And you add them that way. But beyond that, you very rarely need generic code. Most of your code is very specific for a very specific purpose. And you'll find, even in Go, when I was writing a lot of Go, I've written hundreds of thousands of lines of Go, I very rarely even needed generics because it's thing, except for when I wanted like a generic data structure. Every other time it was very specific code and it worked fine. And if I needed something a little bit more generic, the interface system in Go was very fine. And again, that's why features in C or C alone, not just Odin, you can have make a V table of such and do it that way if you necessarily need it, that sort of code. Like file streams are a very good example of this. But in general, like I find that parapoly is very rarely needed, but when it is, it's extremely needed.
Okay, makes sense. So in another direction with language features, why are nullable pointers okay?
So to me, A null pointer is just an invalid pointer. That's all it is. And it's a type of invalid pointer. And there are actually many invalid pointers, many that are invalid, many space, different categories. So the null ones are the easiest to find. So the analogy I like using, which I got from a friend, is the drunk man under a lamppost at night. So a man, he's come back from the pub and he's drunk and he's looking for his keys. And you walk along and says, what are you looking for? I'm looking for my keys. I'm like, oh, okay. And you help him. He's under the lamppost and he's looking. He's like, wait, where did you lose them? It's like, I don't know where I'm losing them. So why are you looking at the lamppost? Well, I can see here. And the reason as to I'm calling it that is because they're the easiest class to catch. Because most operating systems nowadays will reserve the first few pages and allow you not to do much with them. So if you try to access that first page, it'll say, it's an invalid pointer request or something like that, null pointer dereference or whatever it will be specifically. And most of yours will be in that category. Some of them will be just complete random garbage data or it'll be hanging pointers. So null pointers are trying to solve that one specific category, which is very different. Empirically, they're very easy to count. Now, some people want to prove that they are never going to be hit. And I'm like, okay, you want valid pointers, so effectively valid references in your language, reference type, not necessarily pointers. And it's like, okay, you want to do that approach. My approach is I just do heavy loads amount of testing. And it's like, okay, they're the easiest one to catch. And they're very rare as well. Not rare, but rare that they become a problem. Of course, they are problems. Many big software has had issues with null pointers, of course. But I also don't think they're necessarily a mistake. Which is when people like Tony Hall would say there's $1 billion mistake. Because my question is, well, what's the alternative? And the alternative really is, you've got to have a different type system which cannot have the concept of an invalid memory address, which is very, very difficult to design and may not be very useful for certain domains. So you have this balancing act of deciding between, do I want to have this trade-off or that trade-off? And there's no perfect solution.
Okay. And one of the things I find interesting about Odin is the calling convention that provides an implicit context parameter. How do you decide what goes into that context?
So the context system is effectively, in each scope, there is an implicit value named context. The context variable is local to each scope and is implicitly passed by pointer to any procedure with the calling convention Odin, the Odin calling convention. The main purpose behind this implicit context system is for the ability to intercept third-party code and libraries and modify their functionality. So one such case is modifying how a library allocates something or even logs something. In C, some libraries will achieve this by defining macros for them, and you redefine those macros and they're overridden so that the user could define what he wanted. But the problem is, not many libraries do this or support this in many ways, not even a nice way. Like there's many C libraries where, I can't even override the memory allocation just to track it and see what's going on. It's just a hard coding malloc in there or whatever. And I'm just wondering like, okay, I don't want to change how you allocate. I just want to see how much you're allocating and where you're allocating. Just having my own custom allocator. So many languages cannot intercept this third-party code in a neat way. So this context system is pretty much designed for that specific purpose. So within that context system, defining what you want to put in there, by default, usually at the moment, we have a general allocator, the first allocator, which is the default one. For specific implementations, it'll either be like just a general heap allocator, or it would just be nothing if you defined it to be freestanding. We have a temporary allocator, which is a ring buffer, which is thread local for each kind of context. And it just means that you can just allocate memory in a ring, nice little temporary allocator. It's very useful because you can make Odin kind of can feel really high level because you don't have to worry about freeing memory because these are very temporary allocations. Again, it's very dangerous, but you can always change it to a different allocator if you necessary. It's very easy. Another one is in there is a built-in logging system. It's very useful, and you can also intercept it at different scopes and say, we didn't want a different logger here, which is a different logger here, but it's all global, and you don't have to remember calling the specific ones. It's just localized. And then other stuff in there as well would be some general user things. So people can pass a parameter as they need as such. So it's like a pointer here. So you can technically emulate kind of closure-like behavior if necessary. Because Odin doesn't support closures that are standard old procedure literals that are non-capturing. So, but this context system actually allows you, it is a hack, by the way, notice this is a hack and a bodge, but it allows you to have those sort of things and do some really clever stuff with it if the library was not designed to allow for a normal user parameter.
Okay, very nice. So what are some great examples of software that's been written in Odin?
Yes, so currently for my main job, I work with DjangoFX, which creates Embergen. So Embergen is a real-time volumetric simulator that can instantly simulate, render, and export flipbooks for in images and VDBs. So this is for fluid, for fire, smoke, and explosions and such. So it's very good in games and film. So this, we are writing this all in Odin. There's probably about 10, at least 10 programmers now working on this. So we're all working in Odin, and this is a very big project. It's absolutely brilliant. It's a brilliant piece of software. And we're all using Odin to write it in right now. So it means Odin is in production. Even if Odin is not officially released yet, it is pretty stable at this point.
Okay, awesome. And when does 1.0 come out?
There is no official release date, but 1.0 will be when the language adheres to a written specification. It is heavily tested. The tooling and the core library are defined as well. And then when that's done, it will be classed as 1.0. The language effectively is about done. There's a few things we need to add here and there. For instance, I'm currently working on inline assembly for the language. So that's one thing we need to write. So I need to write a full-on assembler for different platforms as well, and make sure that works embedded in, because it's a language. The inline assembly has to know the parent language as well to make it work. So it's going to be kind of more old-fashioned rather than just GCC style opaque string. That approach I think is dreadful. So that's doing that. So it's trying to find out which bits and where you want to place them.
Okay, awesome. I always love to see 1.0s. Anyway.
Yeah, same here.
Okay. So do you have any closing words?
The first one is just, okay, thank you very much for letting you host me here, and it's been a very nice conversation. But in general, if people want to find out more about Odin, just go to odin-lang.org, and you can find out more about their special documentation, downloading the latest to build, and so on and so much. And also join the Discord for Odin if you'd like, because it's a nice little community. You can always have as many questions as you like, and someone will be very free to answer your questions. And again, my question to everyone is, if you're looking for a new language, try and test as many languages as you possibly can to see what language is good for your specific problems. Because one language may not be good for you, but another one will be brilliant.
Awesome. Well, I appreciate your time today. Thank you very much.
No, thank you very much, Tom. It's been very fun.